Hello folks. So, data DevOps. It's really hard. So, if you go to most DevOps talks, you'll have the guys talking about how amazing and easy it is for applications to do DevOps. There's always some guy at the back that sticks their hand up and goes, so what about the database? And it's like that's sucking that air going through the teeth. It's just like that builder that comes around your house and gives you a quote. You know something bad's going to happen. They always go, it's hard, we don't do that. And that's really what the situation has been for many years. It's been shown by the fact that the recent State of DevOps report that runs every year, this is the first year that they've even mentioned data DevOps. And I think that's because there is a much more stronger appetite to adopt a DevOps mentality across the board. Now, we think it's hard, but we actually think it's harder to do DevOps for databases. But we fundamentally believe it's possible because we've been doing it for many, many years. So I'm Simon Sabin, and I run a consultancy in the UK which focuses on data DevOps. We focus on the new modern data platform, and we help companies basically fit their data platform into that whole agile data transformation that they're trying to do for their whole application development. So today what we're going to look at, hope in 20 minutes, is what's possible to show you that it is possible, and to give you a flavor of what you can do and what you can go away with. So how many people are doing data DevOps at the moment? How many people are doing DevOps? Okay, right. I won't ask you why you're not doing data DevOps, because it's hard. What I've got here is, you might have seen this little thing going on down here. I've got a little application which is hitting a database, an Azure database, and this is a scenario that we had at one of our customers that they were storing credit card numbers in their database, like most people do, until their PCI compliance people come along and go, that's not allowed. Now the problem was they had a legacy application which they didn't feel that they could change because they didn't have the code, and so how can they go and start doing encryption of their credit card numbers without affecting their database, and do it in a way that's not going to go and bring down their systems? So what we've got here is, I've got a little release that is pending approval into my production environment, which is going to deploy a set of changes. So I'm going to approve this release, and what this is going to do is deploy the changes required to make this data secure. At the moment, if we go and look at the database, we will see the fact that we are storing lots of card numbers unencrypted. Bad, very bad. So we are going to do a fairly complex data transformation which is going to replace that table with a view, change the view to, put the data in another table, put a whole load of encryption keys in the database, and put some triggers in place so that when you insert data into the table, it goes into the encrypted table, and when you read the data, you get the data back in a secure form that your application can go and use. Hopefully what you'll see is that this application will just carry on running and it won't skip a beat as we go through the release. So you'll see the release is now in progress, and if we go and have a look at the log, that goes through and it takes about 3 minutes to go and evaluate what is being done, and so we'll come back to that shortly. So what we're going to focus on today is some of the aspects of DevOps. The development story, the testing story, the monitoring, and how some of the things that you can do to make it work. So fundamentally, from a DevOps process, you need to have that continuous cycle. You need to be able to deploy it, or develop it to start with, and deploy it, and throughout that journey, do your testing and monitoring. Now, we believe that testing is not the thing that you should be focusing on. You should be focusing on the monitoring bit. Most people have got systems in production, And you need to monitor to make sure that if you're deploying stuff into production, you're not going to break things and screw your customers over. So monitoring is the thing that comes first, and fundamentally testing just consists of two aspects: executing some thing against your service and monitoring and making sure that they're the same, that they're doing what you expect. So monitoring for us is the really critical thing. When you get into the database world, you can do lots of different capabilities in those areas in terms of your development. Source control, how many people have got their database source controlled? Okay, not as many that are doing DevOps already, which is rather worrying. But putting your database in source control is the first step. Doing pipelines, doing testing, doing performance testing, different types of testing, doing different types of deployment, manual, automated, doing validation of your deployments. And then your whole testing capability, there's loads of different testing that you can do. So if we go and have a look at some of those development stories, we believe in using SSDT and a model-driven approach to doing database deployment. How many people do ARM for doing deploying of their Azure stuff? Most people? So ARM is essentially a desired state type model. You just say what you would like, and you then give it to the Azure Resource Manager, and it goes and tries to make it how you would like it. SSDT and the model-driven approach is the same thing. You define your database how you like it, you give your database to a service, and the service goes and figures out how to make a change to your database. That's one way of doing it. The other way is to do the migration approach. If you're using Entity Framework, you're probably familiar with that migration approach, where you define, I want to go from here to here, so I add a column. So I have a script that adds a column to a database. Now, that is by far the easiest way of doing database deployments, but the problem is you don't have a single version of the truth, and it leads to lots of other little challenges if you're doing branching and other sort of strategies. So we believe in the database model approach using SSDT. So if we go and have a look at our database in this situation, very simply, we have a database here which consists of a table with a view on top of it and then some descriptions. And if you look over here, sorry I can't make it any bigger, but the Test Explorer, we have a number of tests. How many people are doing database testing? That doesn't surprise me. I think I saw 2 hands there. Not a huge amount of people doing database testing. Now, how many people are doing C# unit testing or Pester testing? Almost everybody. We actually believe that the best thing to do for database testing is just put your database testing in C# unit tests or Pester tests, because that's very easy. That T-SQL-T stuff is really good, but actually, most people are much more comfortable in C# and or PowerShell. And that's what we've got here. We have a number of tests. We have a test to make sure that all our columns have got a description in our database project. And we also have a test to make sure that our view is returning the right amount of data to the right type of people. Now, if I go and make that, so we have some failed tests. That's because my database isn't correct, because this description here is wrong. So if I go and change this and go and run it now and rebuild my project, what we've done is we've just done some basic capabilities within our test classes to go and take the DAC pack that is built from the database project and deploy it, and then be able to run our tests. And hopefully our test should now go off, and at least one of those should go green. The other one is I've spelt my group that is giving access to my view wrong. So if I go and change that and rebuild, then that goes off and we'll go and deploy it again. Now, I've actually got a capability here for doing live unit testing straight against the DAC pack. And that means that you can go and do your unit testing and do your live unit testing, and you get your feedback a lot earlier. Part of the problem with database testing is that generally you have to deploy it, run some regression testing, and that's very slow. You don't get that feedback quick enough. I believe you can do some of that in T-SQL, in C#, in Visual Studio, using the live unit testing capability. So now all our tests are passed, we're happy, and I've got that feedback within a few minutes, and all's good. Now, anybody been watching this? Did it skip a beat? No errors occurred? And if we go off and look at our database, we should find, let's go and check the release first, that's probably the safest thing. Yeah, the release has gone through. My release deployment should go and show me the script that was run. So you've got good eyesight. You'll see that we are deploying a whole load of code, putting some certificates in. And if I go and look at my database now has got all my data encrypted. My card numbers are not being stored anymore. But importantly, my application that only understands that card table is still getting its data back in an encrypted in a way that it can use it. Now, there's a compliance bit, which we can talk about later if you want to have a chat about it. But fundamentally, at least the data now is stored in an encrypted way. And we've done that all using SSDT and Visual Studio Team System. Sorry, Azure DevOps. So in terms of development, the simplest thing is to develop with just a bunch of scripts. Now, if you're doing stuff with a bunch of scripts, then you can just use PowerShell to do that deployment. I mean, I was doing that type of deployment for my database using DOS batch files 20 years ago. Yeah, things were still possible then. The power of the model-based deployment means that you can have a nicer experience, but you don't necessarily have so much control about what gets done. Our development story of choice is Visual Studio for SSDT, Management Studio, or Visual Studio Code. There are other tools, so the ready roll capabilities that are now in Visual Studio are good if you want to do that migration approach, but have a bit more capability. Coming on to the testing bit, we saw about the testing, and let me just need to kick off another release. Let me go back to here. You'll see I had another release here, and what I've got is coming on to the testing approach, I've got a release here which has failed. Now the reason it's failed, let me just get rid of this, don't need this anymore. The reason this has failed is because we've put some testing, just some basic pester testing in our release pipeline to go and make sure that some of the performance stats that we're getting from our monitoring tool don't change against the baseline that we've got. If we go and look at the test results, we will see that we've got a test which is key lookups. So key lookups is a good metric from a database perspective. If it changes, it generally means you've changed your queries or your indexing in a bad way. So you don't really want it to change hugely between releases. So we've got a baseline test here that says it shouldn't be less than 50,000 compared to what it was before. And that's broken. And we've put that test in our release so that someone that's made that change and that release hasn't gone to production and affected our users, which is a fantastic capability. I actually have a fix for this already, so I'm going to create a release and find my fix. And that will then get deployed. So we will leave that running. Now what we've also done is integrated with some one of the industry tools. So SentryOne is an industry tool for doing database monitoring. Oops, that's not a good thing. Don't look at my password. Oh, that VM is not going to connect. So what we've done is we have connected with SentryOne, and if you've used Application Insights, one of the nice things you can do is you can tell it when a release is going on. So we've done something very similar with SentryOne. We've put some information in a table in a database, in the database. So if we look at this database, which has got our release in it, you'll see there's a deployment history. And so this shows us the deployments that have been gone into the database. And you can then visualize that in your monitoring dashboard to be able to correlate, oh, there's a performance problem there, and that's related to a release. If we go back to our release, hopefully, it's now gone through. Oh, that's not good. My team is probably using the builds. So what we would have seen is the fact that the release would have gone through, and because we've got approvals on our release to production, the testing will have passed, and we can set that approval process in place to approve it to go into production. So from a testing perspective, C# unit tests, Pester is a good thing just for running PowerShell tests, because it means you can pull data from anywhere and it's very easy to manage. T-SQL-T, but also if you're doing big data-y stuff, there are other components like Legitest, which allow you to essentially write write C# unit tests in your test framework of choice, MS Test, XUnit, NUnit, and then they will go and get run in your usual test runner. From a deployment, that's sort of dependent on how you're going to be doing your development. DACFX is your SSDT-based deployment. Redgate CI is the other option. There are other components. So who's using SQL Data Warehouse? Anybody? Okay. So SQL Data Warehouse doesn't get support in SSDT at the moment. But what you can do is, if you just have a bunch of files, you can. We've got a. If you look at that, this GitHub PowerShell module, what we do is we deploy all of those files into a development model, and then we can use the PowerShell module we've got to essentially generate the diff and apply those diffs to your production SQL Data Warehouse. Similarly, things like SQL Agent don't have native support in SSDT, and we've got some PowerShell capabilities there to be able to do your deployment of your SQL database. Monitoring. There are lots of industry standard people for monitoring. SQL Azure has now got capabilities to push into App Insights, which is fantastic. So SQL Server Analytics isn't analytics on SQL Server. It's all about the monitoring of SQL database. And then there's lots of third parties that are very good. But fundamentally, from a database DevOps perspective, you need to understand more than T-SQL. You can't do diddly squat in T-SQL apart from query a database. You can't write any programs really that do anything useful from a DevOps perspective. So you need a language of choice. All our guys fall back onto PowerShell. And fundamentally, every tool is going to take you some way, but you're going to have to use some PowerShell to take you the full way. Database DevOps is hard. Automating that whole database deployment pipeline is very difficult. Do not try and eat the whole elephant. If you try and eat the whole elephant, your boss is going to be wondering what you've been doing for 6 months. You need to take things small. For us, the key is building a bridge to be able to release your code. Find out what it is you need to do that. You don't need to be able to deploy everything, just deploy some things and build upon that. And you don't need the big Y bridge. You might be able to get away with a little rope bridge that just gets your stuff into production. Don't try and do the big thing. The big thing is the thing that's wrong. I was in Donovan Brown's talk yesterday, and very interested about his point about pick the thing that is your pain point. Try and automate that thing. That's really good. It is hard, and it's going to be expensive for your companies to invest time in doing a DevOps for data process. What I would say, though, is that compliance is a big thing at the moment, and having a DevOps story for deployments gives you a much, much better compliance story. You've got complete traceability. So if you can hang your database DevOps story off a compliance story, you can get that funding generally to be able to do that automation. So in summary, there are some tools, but they're not going to get you all the way. You're going to have to write your own things. So you've got to extend your unit testing to be able to connect to databases and do some of those things. One tool won't cut it. You need to be able to extend that by using things like PowerShell. It will be hard, but start small and do small bits. And compliance really is a good way of getting some buy-in to get that achievement. But fundamentally, it is possible. And if you've got any more questions or any questions, feel free to come and ask me. I've got some packs of cards here for anybody that wants a pack of cards, because we think it's magic. But anybody can do it. So yeah, thank you very much.